So let's move on to other examples. So here's this positive, negative, or zero example. Very good. Let's talk about looping or repetitions. Okay, so let's do that. I simply name this version 5, right? And we move on to another demo. Very good. And let's discuss loops. So these counters are very often used to control the loops. So let's copy and paste the counter. And let's say that we want to repeat something on the screen 10 times or 5 times. How could we do this? We could use a statement like this: while count greater than 0. Let's print something. Just say count is positive, right? Remember, we've used this, right? So count is positive. And so that should print. Let's also display the count so that we say what the count value is, and we say like this, positive. So what this loop does, or what this while structure does, very similar to if, it evaluates the condition. If the condition is true, in our case, by the way, it's not true. But if the condition is true, it will execute whatever's inside the body of this loop, or the body of this while structure right here, which starts with an opening brace and closing brace like this. And it will simply go right back to check this condition. Okay, check condition, execute the statement. Again, check the condition, execute the statement. As long as this condition is true, it will continue. As soon as it becomes false, it drops out and goes to the next line after this closing brace, right? So right now, this will not print anything. It just basically is equivalent to an if statement, right? If count is greater than 0, then print the count and say it's positive. So the while does the same thing. It just simply checks the condition and says, oh, condition is false. It will never execute. But let's make this count non-zero. So let's say we set it to 5, right? So in this case, we start this program. The counter will be greater than 0, so it will say positive. And it will keep doing it because the counter never changes, and we just keep doing it, and we're printing this, and we have this endless loop. So we should recognize that count in this sample is a loop controlling variable, because this is the only variable that controls whether the loop executes or not. So typically what we want to do is that we want to control it by saying, okay, minus minus count. So this way we decrement the count, right? So what is expected now that, of course, it's positive to begin with, then it will be printed, then it will be decremented. So it will become 4, 3, 2, 1, and finally 0. But 0 we should not see because 0 is not greater than 0. Run it very quickly. Right, so we have this output which is expected, and so this is a classic example of a loop, right, with some values that we generate during the loop based on this counter, and we keep changing it, and this is a quite expected result: 5, 4, 3, 2, and 1. Now remember that I could also, if I just wanted to wait for the zero value and drop out, I could simplify it this way, and I can say count is non-zero, right? Now remember, this simplified version of a Boolean check for whether count is true or false is simply any time is non-zero, it will be true. And only when it becomes zero, then we drop out and we stop running our program. That's why I changed my message here to non-zero, because negative will also be true, including any positive value. Let's just make sure that it all works. Run quickly. You see that now it prints this. Changes to non-zero, but the output exactly the same. Just an observation. Okay, so that's an example of a loop, and just a very simple thing, right? Just like an if statement, while can check this. By the way, the else part does not exist for while, only for if. So here, else you cannot use. Only while is quite simple. Just the way it's written, it is what it is. Exactly the same loop can be also written with a for statement, the control statement, which is a for loop. Let's see what else we have. In our example. So here we have this example, which was the first real program running on stored program computer example here, which is similar to what we do. All right. So just to give you a sample, I simply will copy and paste this. Since we're discussing loops, it's not very difficult to move from. So this was my version 6 of demos today, and now I will change this to a for loop. For loop looks like this. And so let's just bring back count greater than 0. Perhaps for our demo it will be a little bit easier to interpret it. So let's run this program and see what it prints. So I changed it to like from this to this. And the output is exactly the same. And so let's discuss what is happening with this loop. Just a few highlights and few notes about this. That's the output that it generates. So the way it works is that the for loop, in fact, is designed specifically for situations where we have a direct, direct interaction or direct computation related to the loop control variable. In our case, obviously, it's a count that goes from 5 to 0, and we print these strings. So whenever we have a very distinct example of a loop controlling variable, for should be your choice. This really should be your choice. If the count was not, designed to loop like this, and modify itself in a series of decrements like we do here. Perhaps it was just simply if it would depend on user input. Then the proper type of loop would be a while loop, because while loop is considered to be general purpose loop for any sort of conditions, not necessarily related to any kind of loop controlling variables. You could be just checking the state of the device. Is the device ready? You never know when it's ready. You're just looping and keep checking. Device is ready or not, right? So there is no clear case of a loop control variable. But in cases like this with the counter, which is very typical situation of the loop, based on some kind of value which gets incremented or decremented and takes a range of values. This is what we should be using. So its structure is like this. I just write it on top here, like essentially just like a pseudo code, right? For loop in general has initialization part over here, condition. Now notice that this condition is not required to use parentheses. With an if statement and a while loop, we have to use parentheses. We're forced by syntax. Here, we don't do it. And this is, generally speaking, some kind of increment or decrement statement. So this is like 3 parts, right? So if I want to highlight this, this would be initialization part, right? This will be the condition part, and this is the part that generally speaking is called increment or decrement statement. 3 parts. And then I'll copy and paste this, and I'll show you this, that this can be empty, this can be empty, and this can be empty with the for loop. When initialization is empty, it just means, okay, there's no initialization, nothing happens. When condition is empty, it's always true, right? So when the condition is absent here, it's the same as true. So therefore, it's an endless loop. And of course, when increment decrement part of the for loop, and something happens inside this loop, we repeat it. So this is simply an example of a forever loop, or truly endless loop. By the way, again, compared to the while statement, to make an endless loop with a while statement, you would have to do something like this, right? If true, forever, right? True is always true. This loop will loop forever. Okay, so here is this is an example of a forever loop with all parts, initialization, condition, and increment, decrement. They're all missing.